Oracle Explain Plan provides a detailed description of the steps Oracle will take to retrieve the data requested by the query. The optimizer considers various factors, such as the available indexes, the size of the tables involved, and the complexity of the query, to determine the optimal execution plan. The Explain Plan shows the order of operations that Oracle will use to execute the statement. It includes information such as the operations that will be performed, the order in which they will be performed, the estimated number of rows that will be processed at each step, and the estimated cost of each step. These are some of the key items to look for when analyzing an Oracle Explain Plan. It provides insights into how the database engine is executing the query and can help identify potential performance issues or optimizations. The Explain Plan output typically consists of several columns providing information about each step in the execution plan. Here's an example of what the output might look like. ID column displays the step number in the execution plan. Operation column displays the type of operation being performed, such as table access full for a full table scan. Name column displays the name of the table or index being accessed. Rows column displays the estimated number of rows returned by the operation. Bytes column displays the estimated number of bytes returned by the operation. Cost, %CPU, column displays the estimated cost of the operation, measured in arbitrary units. Time column displays the estimated time taken by the operation. Start column displays the partition range start value. Stop column displays the partition range stop value. Also analyze access paths. The access paths used by the optimizer to retrieve the data should be examined, such as full table scans, index range scans, or nested loop joins. Indexes, check the index usage and the columns being indexed. See if you can add or modify indexes to improve performance. Join types, check the type of join used, such as nested loop joins, hash joins, or sort merge joins. Cardinality estimates. Cardinality estimates are the estimated number of rows returned by a specific step in the execution plan. Check whether the estimates are accurate or not. Inaccurate estimates can lead to suboptimal query performance. Cost. The cost represents the estimated resource usage for a particular step. Look at the cost of each step in the execution plan. Check the high-cost operations that may be causing performance issues. Predicate. Look at the predicates used in the query. Check for any unnecessary or redundant predicates that can be removed to improve performance. Filter. Any additional filters used by the query. Parallel operations. If the query is running in parallel, check the parallel operations being used. Parallelism can be beneficial for some queries, but it can also cause performance issues if not used correctly. Sort. Check the sort operations used by the optimizer. Partitioning. Check if the query is using partitioning. Statistics. Check if the query is using statistics. Also look for the number of rows returned by each operation, the estimated time for each operation, the estimated number of bytes that will be processed, the estimated number of disk I/O operations in the I/O column in the execution plan, the estimated number of CPU cycles used in the cost column in the execution plan, the estimated number of memory operations in the start/stop columns in the execution plan, the estimated number of logical reads, the estimated number of physical reads, the estimated number of consistent gets. Check the redo size. Redo size represents the amount of data generated by changes made to the database. Check the number of recursive calls. Recursive calls in Oracle are calls to a stored procedure or function that calls itself. This type of call is used to perform a repetitive task, such as looping through a set of data or performing a complex calculation. To generate an explain plan, you can use the explain plan statement or the dbms_xplan package. dbms_splan is an Oracle package that provides a way to display the execution plan of a statement. This package can be used to examine how a query is executed, which can help in identifying performance issues and improving query performance. The following are some of the options available with dbms_xplan. Display to format and display the contents of a plan table. Display underscore AWR to format and display the contents of the execution plan of a stored SQL statement in the AWR. Display underscore cursor to format and display the contents of the execution plan of any loaded cursor. Display underscore SQL underscore plan underscore baseline to display one or more execution plans for the SQL statement identified by SQL handle. Display underscore skillset to format and display the contents of the execution plan of statements stored in a SQL tuning set. Some of the most commonly used options for displaying statistics include all stats rows, cost, CPU underscore cost, IO underscore cost, partition, outline, predicate, timing. Select asterisk from table, dbms underscore xplan dot display underscore cursor. Select asterisk from table, dbms underscore xplan dot display underscore cursor, format equals all. Select asterisk from dbms underscore splan dot display underscore cursor, SQL underscore ID, child underscore ID. Select asterisk from table, dbms underscore xplan dot display underscore ID, format equals all plus predicate. Select asterisk from table, dbms underscore xplan dot display underscore cursor, format equals advanced. Select asterisk from table, dbms underscore xplan dot display underscore cursor, format equals all stats last, SQL underscore ID equals your underscore SQL underscore ID. Select asterisk from table, dbms underscore xplan dot display underscore cursor, cursor underscore name, all plus outline plus predicate. Exec dbms underscore splan dot display underscore cursor, format equals all stats last plus report underscore level underscore stats. Exec dbms underscore splan dot display underscore cursor, format equals all stats last plus display underscore iastats. Exec dbms underscore splan dot display underscore cursor, format equals all stats last plus display underscore pustats. Exec dbms underscore splan dot display underscore cursor, format equals all stats last plus display underscore memory underscore stats. Exec dbms underscore splan dot set underscore ev, event, 10,053 trace name context forever, level 1. This option sets the optimizer environment variables for a specific session. Select asterisk from table, dbms underscore xplan dot display underscore cursor, format equals all stats last, SQL underscore ID equals your underscore SQL underscore ID. The bind variables will be listed along with their values. If there are multiple executions of the query with different bind variable values, you will see multiple entries for the bind section. Peaked underscore bind underscore values section. This section contains information about the bind variable values that were used during the query optimization. Using the gather underscore plan underscore statistics hint makes the optimizer gather the actual cardinalities in addition to the expected cardinalities in the execution plan. This can then be reported by the display underscore cursor function if the format is set to all stats. Select /* plus gather underscore plan underscore statistics */ from EMPE, department dworry.depno equals d.depno any.aname equals Smith. Select asterisk from table, dbms underscore xplan dot display underscore cursor, format equals all stats last. To ensure an Oracle query uses the best execution plan, you can take the following steps. Query optimization, start by improving the query itself. Make sure you've constructed the query as effectively as you can by using only the relevant columns, using the right indexes, and eliminating subqueries when you can. Check clustering factor of the index, compare it to the number of rows, check if full table scan are needed or avoided when not needed. The goal of the query optimizer is to see if the query can return as less rows as possible. Collect statistics. Oracle creates the execution plan using data. Therefore, you must verify that the statistics on the tables, indexes, and columns are current. The dbms underscore stats package can be used to collect statistics. Use the appropriate optimizer mode and initialization parameters. Oracle offers rule-based and cost-based optimizers. The default cost-based optimizer often offers greater performance. However, you might have to switch to the rule-based optimizer if your database is older or you have a particular requirement. Make sure correct cursor underscore sharing parameter values are used that will help in reducing cost involved in parsing. Use hints. Utilize Oracle's provided hints to direct the optimizer as it creates the execution plan. The access method, join method, or index to be utilized can all be specified using hints. Use SQL profiles and SQL plan management. The optimum execution plans for your SQL statements can be captured and chosen using Oracle SQL plan management. When handling complex queries or when the data distribution varies over time, this functionality is quite helpful. Check if the wait events are related to contention in shared pool. To mitigate latch contention in the shared pool, you can take several steps. Increase the size of the shared pool to provide more memory for caching data structures. Tune the application to reduce the number of shared pool allocations or deallocations, such as minimizing dynamic SQL or optimizing stored procedures. Optimize SQL statements and reduce the use of literals to encourage the reuse of shared cursors.